Betelgeuse, a massive red supergiant star located in the Orion constellation, is a remarkable celestial object that has captured the fascination of astronomers and astrophysicists alike for a long time. If it were situated at the center of our solar system, its dimensions would extend far beyond the orbit of Jupiter, outshining even the Sun. This colossal star's physical presence is immense, and it is also going through significant changes that could lead to a cataclysmic event on an extraordinary scale. Scientists, including renowned experts like Brian Cox, have expressed concerns about Betelgeuse, as it has been sending unusual signals throughout space. These developments have raised an important question. Could we be on the verge of witnessing a spectacular explosion that could drastically alter the night sky? The mystery of Betelgeuse remains a source of intrigue for the scientific community. Much like living organisms, stars undergo birth, life, and death in ways that often challenge our understanding. Betelgeuse, a red supergiant, resides on the outer edge of our galaxy and has been the subject of much interest due to its immense size and advanced age. Its reddish hue and variable brightness have consistently attracted the attention of both amateur and professional astronomers over the years. Its fluctuating luminosity and color changes have sparked curiosity, but recent events have escalated these questions regarding its future. As Betelgeuse approaches the end of its life cycle, its sheer size is evident. It is roughly 1,000 times larger than the Sun. So large, in fact, that if it replaced the Sun, its outer layers would stretch far beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and Mars in the process. This tremendous size reflects its current state and its position in the stellar evolutionary process. Having exhausted the hydrogen in its core, Betelgeuse is now expanding and cooling, signaling that its end is near. Betelgeuse is estimated to be around 8 to 8.5 million years old, which may seem relatively young by human standards, but it is ancient in terms of stellar lifespans. Over the course of millions of years, this star has undergone dramatic transformations, evolving from a hot blue star to the cooler red supergiant it is now. These changes are driven by the balance between nuclear fusion and gravitational forces, which cause stars to expand and contract throughout their lives. The red color of Betelgeuse is a result of its lower surface temperature compared to hotter stars like the Sun. While the Sun's surface temperature is around 5,500 Kelvin, Betelgeuse's is much cooler, about 3,500 Kelvin. This cooler temperature makes Betelgeuse emit light at longer wavelengths, giving it its characteristic red appearance. However, this color change is more than just an aesthetic feature. It provides astronomers with valuable insights into the star's internal processes and ongoing evolution. Betelgeuse's color and brightness have not been consistent over time. Ancient civilizations, including the Romans and Chinese, once described Betelgeuse as yellow, and it wasn't until the 9th century that Arabic astronomers observed its shift to red. This color shift marks the star's natural progression from a hotter, younger state to the cooler red giant we see today. In addition to its changing color, Betelgeuse is classified as a variable star, meaning its brightness changes over time. These fluctuations can occur over both short-term cycles lasting days and longer-term patterns spanning years. The variability in Betelgeuse's luminosity adds to its mystery. Unlike other stars, which exhibit predictable brightness trends, Betelgeuse sometimes deviates from these patterns, suggesting that complex, not yet fully understood processes may be occurring within it. One of the most notable events in recent history was the unexpected dimming of Betelgeuse in 2019, known as the Great Dimming. This unusual phenomenon sent ripples through the scientific community, as Betelgeuse, typically one of the brightest objects in the night sky, lost much of its brilliance. The star's brightness decreased at a rate of 0.01 magnitudes per day, reaching its dimmest point in February 2020. This drastic change raised many questions about what was happening to the star. One of the challenges in studying Betelgeuse lies in the delay between an event and its observation on Earth. Light from Betelgeuse takes more than 725 years to reach our planet, so when we observe the star, we are essentially looking at how it appeared in the past, not in real time. This time lag makes it difficult to track rapid changes in the star's behavior, complicating efforts to predict or explain its fluctuations. In response to these unusual observations, astronomers, including Andrea Dupree from the Harvard Center for Astrophysics, have been closely monitoring Betelgeuse using advanced instruments like the Hubble Space Telescope. These observations have yielded valuable insights into the changes occurring in the outer layers of Betelgeuse's atmosphere. Data from the Hubble Space Telescope showed that material was being ejected from Betelgeuse at speeds of up to 200,000 miles per hour, forming a dust cloud that partially obscured the star's surface and contributed to its dimming. This rapid mass loss has led some scientists to speculate that Betelgeuse may be nearing an even more dramatic event, a supernova. Is Betelgeuse on the verge of a supernova? The big question is whether Betelgeuse is on the verge of exploding in a supernova. A supernova is the violent death of a star, and if Betelgeuse were to reach this stage, its explosion would produce an incredibly bright burst of light, visible even during the day. This event would outshine the full moon and offer a unique opportunity to study the final moments of a massive star's life. However, despite the spectacular nature of such an explosion, Betelgeuse's distance from Earth, about 725 light-years, ensures that no direct harm would come from the event. Several theories have been proposed to explain Betelgeuse's recent dimming. One hypothesis is that it marks the beginning of the star's transition to a supernova. Another possibility is that a cloud of dust, formed by the star's ongoing material loss, is obstructing its light. Some researchers suggest that the dimming could result from changes in Betelgeuse's outer layer or photosphere, possibly due to the formation of a large dark spot on its surface. Regardless of the cause, Betelgeuse's dimming remains a significant area of focus for astronomers. The importance of studying Betelgeuse. Red supergiant Betelgeuse are crucial to our understanding of stellar evolution. These stars represent the final stage of a massive star's life before it explodes in a supernova. Their immense size and relatively short lifespans make them ideal subjects for studying the processes that lead to a star's death. Furthermore, the energy released by these stars during their final stages contributes to the formation of heavy elements, which are essential for creating planets and life as we know it. Should Betelgeuse explode, it would provide an exceptional opportunity to observe a supernova up close. Supernovae play a key role in enriching the interstellar medium with heavy elements, which are then incorporated into new stars, planets, and possibly life. The eventual supernova of Betelgeuse could have profound implications for our understanding of these cosmic events and could provide a dazzling spectacle for astronomers and stargazers around the world. While Betelgeuse's great distance from Earth ensures our safety from any harmful effects, the study of its dimming and eventual demise will continue to offer valuable insights into the larger processes that govern stellar evolution. If Betelgeuse were to go supernova, the explosion would release an immense amount of energy, briefly making it one of the brightest objects in the sky. But what happens after that? The fate of the star's remnants depends on its mass after the explosion. 1. Formation of a neutron star or black hole. Once Betelgeuse explodes, the remaining core will determine its ultimate fate. Neutron star. If the core left behind is between 1.4 and 3 solar masses, it will collapse into a neutron star, a dense, rapidly rotating stellar remnant composed almost entirely of neutrons. Neutron stars are among the most extreme objects in the universe, with a diameter of only about 10 to 15 miles, yet containing more mass than our Sun. Black hole. If the core is more than 3 solar masses, gravity will overpower all other forces, and Betelgeuse will collapse into a black hole, a region of space where gravity is so strong that not even light can escape. This would make Betelgeuse one of the closest known black holes to Earth. Scientists are still uncertain about which outcome is more likely, but based on current estimates, Betelgeuse may not be massive enough to form a black hole. 2. Supernova remnant and its impact on space. The explosion will send shock waves through space, expelling vast amounts of material at speeds exceeding tens of thousands of kilometers per second. This material, rich in elements such as carbon, oxygen, iron, and gold, will spread out into the surrounding interstellar medium, possibly forming a new nebula, a vast cloud of dust and gas. This nebula could eventually serve as the building blocks for new stars and planets, much like past supernovae contributed to the formation of our Sun and the Earth billions of years ago. In fact, All elements heavier than hydrogen and helium come from stars, meaning the very atoms in our bodies were forged in ancient supernovae. 3. Effects on Earth and the solar system. Despite the spectacular nature of a Betelgeuse supernova, its 725 light-year distance from Earth ensures we would be safe from any direct harm. However, there would be some noticeable effects. A brilliant celestial display. When Betelgeuse explodes, it will become as bright as the full moon and remain visible in daylight for weeks or even months. At night, it will be the most striking feature in the sky, possibly even casting shadows on Earth. A burst of neutrinos and gravitational waves. Before we even see the explosion, Earth will be bombarded with a wave of neutrinos, nearly massless particles that pass through matter almost undetected. Scientists will also be able to observe gravitational waves, ripples in spacetime caused by the star's violent collapse. No harmful radiation. Although supernovae release X-rays and gamma rays, Betelgeuse is too far away for these to have any impact on Earth's atmosphere or life. The role of supernovae in the universe. Supernovae play a crucial role in cosmic evolution by distributing heavy elements across the universe. Without them, there would be no planets, no life, and no complex chemistry. Some of the key contributions of supernovae include creating new stars. The shock waves from a supernova can compress nearby gas clouds, triggering the birth of new stars. Seeding the universe with elements. Elements like carbon, essential for life, oxygen, iron, and even gold are created in massive stars and spread across the universe when they explode. Forming planetary systems. The material ejected from past supernovae eventually coalesces into new planets, asteroids, and moons. Will we witness Betelgeuse's supernova? The exact timing of Betelgeuse's supernova remains uncertain. It could happen tomorrow, in 100 years, or in 100,000 years. Given that the light we see from Betelgeuse is already 725 years old, the explosion may have already happened, we just haven't seen it yet. Other nearby stars that may go supernova. Betelgeuse is not the only star nearing the end of its life. Other massive stars that could explode in the near future include Antares, in the Scorpius constellation. Another evolutionary red supergiants like Betelgeuse offer critical clues about the universe's development. Their explosive deaths play a significant role in shaping the future of galaxies and star systems. As astronomers continue to observe Betelgeuse's transformations, the knowledge gained from this iconic star will likely offer new perspectives on the broader field of stellar evolution. The study of red supergiants and their eventual fate provides essential information about how massive stars live and die. By understanding the mechanisms driving these processes, scientists can make more accurate predictions about the life cycles of other stars in similar stages of evolution. Betelgeuse's behavior may also help uncover the mysterious factors influencing variability in stars. Astronomers are likely to use Betelgeuse as a benchmark for comparison, studying its fluctuations alongside those of other stars to refine models of stellar behavior. The mass loss observed in Betelgeuse offers a glimpse into the extreme conditions experienced by red supergiants. As the star nears the end of its life, its outer layers will likely become even more unstable, shedding even more material. Understanding this mass loss is crucial for predicting how other red supergiants will evolve. Supernovae are not only awe-inspiring cosmic events, but they are also fundamental to the formation of heavy elements throughout the universe. When a massive star like Betelgeuse explodes, it releases elements such as iron, carbon, and oxygen, building blocks for new planets, stars, and potentially life itself. If Betelgeuse were to explode, it would contribute to this cosmic cycle, enriching the interstellar medium and paving the way for new star systems. The shock waves from a supernova can compress nearby gas clouds, triggering the formation of new stars. Additionally, the radiation released during the explosion can influence the chemical composition of these new stars and planets. Understanding these processes is essential for predicting the future of the universe. As Betelgeuse continues to evolve and exhibit unusual behavior, astronomers will intensify their efforts to study it using advanced tools like the Hubble Space Telescope and other observatories. These real-time observations will provide crucial data that will improve our models of stellar evolution, particularly in areas such as mass loss, brightness variability, and other phenomena that characterize the life cycles of massive stars. In conclusion, the study of Betelgeuse offers an invaluable opportunity to learn more about the life and death of stars, particularly those much larger than our Sun. While our Sun is a medium-sized star with a long lifespan, Understanding the behavior of red supergiants like Betelgeuse allows us to make more accurate predictions about the fate of other massive stars. Moreover, the insights gained from studying Betelgeuse can deepen our understanding of cosmic forces such as galaxy formation, star clusters, and planetary systems. As we continue to monitor Betelgeuse and other red supergiants, we will gain a better understanding of the fundamental processes that govern the universe, helping us answer some of the most profound questions in astronomy. Beyond the excitement surrounding Betelgeuse's potential for a supernova explosion, this star offers a rare look into the final stages of stellar evolution. Its massive size, unpredictable behavior, and impending death provide valuable insights into how stars evolve and eventually perish. The study of Betelgeuse not only helps us understand the intricacies of this particular star, but also sheds light on the life cycles of other massive stars and their impact on the cosmos as a whole. As scientists observe Betelgeuse's evolution, they continue to view it as a natural laboratory for studying stellar death. Understanding its transformation into a supernova, should that occur, will help us grasp how other stars of similar size and composition follow the same path. Supernovae are critical events in the life cycle of a star and serve as pivotal moments in the ongoing expansion of the universe. Betelgeuse's behavior, especially its sudden dimming and fluctuating luminosity, offers astronomers an opportunity to refine their models of how red supergiants behave as they approach the end of their lives. While the exact cause of its recent dimming is unclear, one thing is certain: Betelgeuse is a key piece of the puzzle in understanding stellar death and the cosmic processes that govern it. The significant mass loss observed in Betelgeuse is another fascinating aspect of its final years. As the star sheds material at such a rapid pace, scientists can learn more about the life expectancy and eventual fate of similar stars. This mass loss not only signals Betelgeuse's impending demise, but also contributes to our understanding of how red supergiants affect their surrounding environments. The material ejected by the star will eventually mix into the interstellar medium, influencing the formation of new stars, planets, and other cosmic bodies. Astronomers using both ground-based telescopes and space-based observatories are continuously gathering new data on Betelgeuse. Observations from instruments like the Hubble Space Telescope allow them to gain a deeper understanding of the star's behavior and internal changes, helping to track how stars like Betelgeuse interact with their environments, especially in the final stages of life. These studies also offer new insights into how the rapid mass loss and variable brightness of such stars shape the overall structure of our galaxy. The mass loss from Betelgeuse is of particular interest because red supergiants like this one expel enormous quantities of material into space, significantly impacting the surrounding interstellar medium. This process enriches the medium with heavy elements, which are crucial for the formation of future stars and planetary systems. When these elements are released into space, they become the building blocks for new stars, planets, and perhaps even life itself. As Betelgeuse continues its journey through the later phases of its stellar evolution, astronomers are keenly aware that its eventual supernova could trigger the birth of new stars. The explosion would release vast